Welcome, math students. Today we're going to talk about the law of sines and using it to find areas of triangles. So what I have here is I have pre-typed this out for you. You can see there's three different equations that we're going to learn how to use in order to find the area of a triangle where they don't give you the height. So that's what makes this powerful, is you can have any of the three bases. But you don't necessarily have to know the height, and yet you could still do it with these formulas, and it is amazing. Instead of writing A here, they'd use the letter K, because the capital A, which we usually use for to mean area, is already here for this capital A, for this degree measurement for this angle here. So that's where this K comes from. Now remember, for area of triangles, if we take it back, it's 1/2 base times height. And we don't know what the height is, but here's the trick to this. If I take and extend a line and intersect that, let's say right there, and that makes that a right angle here. You may have to use your imagination a little bit, but let's say that's a right angle. It doesn't necessarily split this in half. Okay, it doesn't necessarily have to do this. The way I did it, it kind of looks like it does. But let's say it hit it down here. Whatever, it's a right angle. And we'll call this h for the height of it. We always measure height from the ground straight up. Like if you go, and they measure your height, they'll say stand straight up, and you'll have to anytime you measure the height of something, it's from the ground straight up at a right angle. And in this case, it's like this. So if we label the other sides, I'll go back to this blue color here and make this side B, side A, and little side C. These are the lengths of the sides here. And I want to use this H to find the area of this. Here's how this is all going to work. If I go from this angle here and I say the sine of capital A. Now I'm not going to put any degrees or anything on this, but if I go from the sine of A, now remember sine means opposite over hypotenuse. And let's just get rid of this. That got ugly there. Okay, now that we've wasted time doing that, whatever. But sine is opposite over hypotenuse. So from this case, if we just look at this little triangle here, formed by this where I'm outlining there, the side opposite this pink angle A here would be H. And the hypotenuse would be this side here, the side opposite the right angle, so that would be C. And if we turn around and solve this for H, just like if we know that 4 equals 20 over 5, and I want to know what 20 equals, this equals 4 times 5, or 5 times 4 is 20. So if we use that example here, H, like the 20, is C times sine of A. So H actually equals C times the sine of A. And if we substitute this H in for this H here, what we get is a formula that it looks like this. A equals the area is 1/2 the base times the height. And in this case, the height is C sine A. That is this formula right here. And that's how they get that. This is the side B. And you could do that for, if I dropped, instead of going from H this way, if I drop the red line there for H down this way, you'll get any of these three depending on which angle you do that from. So this is basically, this isn't a how to do this problem. This is more of a where do these formulas right here come from. And I will talk to you soon.